Hi there. My name is Shawn Burke. I'm a developer for WinForms. And thanks for coming out this morning. We know it's early. You're probably up late studying slides and other conference materials. So we appreciate having you get up this morning and join us for an advanced intro to WinForms. We're going to cover a couple of main topics today. The first slides we're going to cover are going to be really WinForms-centric. But a lot of what we're going to cover today is very general designer interaction and the ways in which you can create components that interact well with the Visual Studio.NET designers. What we're going to cover is 5 basic points. The first 2, as I mentioned, relate directly to WinForms and WinForms specifically. The last 3 are the more general designer topics that talk about how to create components, how to make them with the Visual Studio 7 designer, how to license them. We think that we've got an idea that somehow component vendors, the right components, are interested in getting paid for them. And this is our way of helping those component vendors enforce that. We're also going to talk a little bit about metadata, some general common language runtime features that really give us a lot of ability to add accessibility, to add customization into our designers and the components that our customers are going to create. So let's get started. Let's talk about the basics of WinForms. Hopefully, many of you attended the WinForms basic talk yesterday afternoon, and you learned a lot about controls and about painting and different things you can do with controls. But when you think about creating a control, it really breaks down into 2 basic groups. Control creators can create custom controls. And custom controls are when you can existing control, a list view, and edit a button, and you modify its behavior. You change how it paints, you change what happens when the user clicks on it, etc. The other type of control that you can create is a custom control. When we talk about a custom control, a user control. When we talk about a user control, we're usually talking about a control that has multiple controls in it, but to the outside world it looks like one control. You interact with it like one control, but it may have child controls, it may have some focus setting behaviors. An example of a user control, even though it's actually a user control, to kind of think about what does that mean, is the combo box. A Windows combo box has a drop-down list box, it has a button, and it has an edit field. As a user of a combo box, you don't think about drop-down, .show, or button, focus. You think of the combo box as one entity, and that's a great example of a user control. Many of our customers like to create controls that have child controls and interact with the outside world as one control. So it's an important scenario for us. The other basic thing that we want to talk about for a second excuse me, is integrated designer support. When we designed WinForms, we were thinking about designer support from the beginning. We didn't have a separate team of people in one building doing the designer and another group of people in another building doing the runtime. It's all integrated. We thought about it from the very beginning. The other thing to keep in mind is that just because they're integrated doesn't mean they're inseparable. If you ship components that are concerned with the runtime, you don't need to ship the design time portion as well. But the design and the architecture were built at the same time, and we've integrated a lot of things that make it a lot simpler to add really rich design time support. The other thing we've done is made sure that our components are actually usable in a design time environment. How we've done that is a couple of things. If you've had a chance to look at the PDC preview disk that was distributed yesterday, the property browser, a lot of the server explorer, the WinForms designer, most of the WebForms designer, were all written using WinForms. So we've kind of eaten our own dog food. We've tested the stuff. We're using it in an environment that is otherwise not managed code. The rest of the environment, Visual Studio.NET, is written in C++. All of the WinForms code you see is written in C#. So we're kind of using it as a test platform, as a proof of concept that we can in fact take complex solutions and push them into a shipping piece of code. It's a great avenue for us to show what we can do. So let's talk about the different kinds of controls you'll find in the WinForms framework if you're interested in creating a custom control or a user control. At the very base level is control. Control is essentially our H-wind wrapper. What Control has built into it is generally what you consider user interaction. It has mouse click support, keyboard handling support, mouse move support, and it handles most of the WM underscore messages that you can think of in default ways. Control is kind of our def window proc. It does what we want to do in the very basic case. The step up from that most of our controls that we ship, list box, combo box, calendar, data grid, are generally derived from rich control. What rich control has added to it, besides user interaction support, is painting support and layout support. Layout support, we'll talk about it a little bit later, allows you to very easily customize how your controls interact with the rest of the form. When you resize the form, where do they go? Do they strip? Do they say where they're at? Do they say stuck to another control next to them? Driving from rich control is container control. Container control, as the name implies, is basically about focus interaction. If I'm a control and I have children, how do those children interact with the parent? What happens when I push the tab key? What happens when I push the arrow keys? Container control has a lot of that built in. Also driving from rich control is scrollable control. And again, as the name implies, scrollable control takes care of a lot of the dirty work of making a client area scrollable. And if you've ever tried to implement that in standard C or even MFC, it's a fairly non-trivial task. We've made it really, really easy. Also driving from container control is user control. Talked about that a little bit before. User control itself actually doesn't do much, but what it is, it's a base class from which control creators can start in a designer. So we have two what we call designable classes in the Visual Studio.net. One is form there at the bottom of the list. We'll talk about that in a second. And user control. So you can start up a user control. You can actually get a design surface, and we'll show you that in a second, to begin with, to create a custom control that has children and has some really neat behavior. The last one is form. And form is our top-level window. If you're interested in having a window with a minimizer or maximize button, with a text caption, that supports transparency, form is where you want to go. It's our top-level window. We don't make a clear distinction between dialogue or child forms and top-level windows, much as the way that VB did. If you want to have another window come up, just go ahead and use form and customize its behavior. GDI+. We have embraced completely. All of our painting is done with GDI+. GDI+ offers us and is going to offer our customers a lot of great advantages. GDI+ is the replacement for GDI. It's a completely object-oriented graphics drawing package that offers a lot of advancements over the standard GDI package, but also has some differences. Some of the differences to watch out for, and if you look at the code here, you'll notice, is one thing that you do with GDI, with a handle to a device context, is that you select it in a font, or you select it in a pen, or you select it in a brush. That paradigm is gone with GDI+. If you want to do a drawing operating with GDI+, you need to specify the font or the pen at time. You may be thinking this is a performance issue. It actually turns out to be a much cleaner coding methodology, because you're not in a situation where you may forget, oh, this thing is actually selected in right now, didn't want it to draw with that pen, didn't want it to draw with that font. So taking a look at the code that we have here on the screen, this is really similar to some code that Mark and Fred showed in their Forms intro yesterday. What we're going to do is we're going to take a background brush. We're going to paint the background of the graphics surface with a bitmap. It's a great feature to be able to take a bitmap and use it as a brush. It allows designers and people that are centered on the UI end of product development to really customize the look of their window, and we make it very easy to integrate that into your WinForms application. We're going to wash the brush. We're going to apply a wash brush. Mark showed this yesterday. This kind of smooths down the colors, and it kind of deadens them out a little bit. We're going to add a couple of rectangles. We're going to add a string. So let's take a look at what that looks like over here on number 2. Oops. So what we have here, we're using a little different bitmap, but it's essentially the same code as what you saw up there. See how we have a nice drawn background here. We have a Microsoft.NET background and a panel at the bottom of the window that draws, the wash brush is applied, so it kind of evens out the colors a little bit. If we want something even cooler than that, we can go ahead and do what else WinForms is great for, and that's opacity and non-rectangular windows. So first thing we're going to do is we're going to change this window a little bit. We're tired of square windows. We've been looking at square windows since Windows 3.0 in 1990. So we're going to apply a nice non-rectangular background to that. This is actually really easy to do with WinForms. What you're seeing here is a graphics path, and it just creates a region, and we apply the region to the base form, and that controls which parts of it are going to draw and which parts aren't. If you haven't seen Windows Media Player 7, I would really, really encourage you to download it. It uses a similar technology, not with WinForms, but uses non-rectangular, and it has great skin effects that you can apply to that. So if you're wondering, this is actually legitimately transparent. I can click on folders behind this window right through it. So the regions are not painting, are legitimately not there. Works out really well. Something else we can do if we remove this background here, we can actually change the opacity of the window. If we change this, we now have a slider. We can control the opacity of the window and have some really great alpha blending effects. This is enabled by default with Windows 2000. GDI Plus allows us, this is a Windows 2000 client, but GDI Plus allows us to deliver these features on a non-Windows 2000 platform as well. A demo. Okay, just did that. Okay, so those kind of covered the really WinForms specific part. WinForms is a framework like many others, and creating WinForms controls, if you saw the talk yesterday, is really simple. Using WinForms is really straightforward. We've enabled it with C#, which is an absolutely wonderful addition to the Microsoft languages, but you can actually build WinForms in any other CLR-enabled language. Visual Basic, you name it, Manage C++, etc. So we're going to talk about more now about the general way that you create components that are rich and interact well with the Visual Studio designers, and what it takes to be able to customize that behavior. So the first thing we're going to talk about is properties. If you've been in the C# talks, if you're familiar with Visual Basic, you know what properties are. You can think of properties as smart fields. By that I mean you access them like a field on a class, but what they're actually doing is doing a function call. It's compiler sugar for a function call. So you can do more work than just accessing the field. When I was first introduced to properties, I was worried, well, wait a minute though, isn't this going to encourage people to call functions when they're actually, call functions when they're just calling member variables? Turns out that in the 99% case, these accesses are often very simple. But at Microsoft, one of the things that we do is we differentiate members from properties by using a little different naming nomenclature. We go ahead and call our member variables with a lowercase first letter, and the properties have an uppercase letter. But it's very convenient to be able to access a rich function in a property syntax. And generally, the jitter is going to make that get method, and you tend to get a lot more often than you set. It's going to be a very fast call. The set is actually more interesting. In this case, set is going to say, change the text and repaint. You could raise an event here. You can do whatever you want. It works out really well. So if you look, we have a C# example in code and of the definition, and you see in the purple box there down towards the bottom, that's Visual Basic calling this button. Very straightforward to use. You can use a getter or a setter. The compiler figures out which context you're looking for. Events. Events are the other part of the puzzle. Much like Visual Basic has always been, WinForms is an event-driven framework. When you want to add an event to your class, there's two basic parts to it. The first part is the event handler. And the event handler is a delegate. And what a delegate essentially boils down to is a function pointer. But it's much safer and better than function pointer because it has security built in, has access built in. So the event handler is what holds on to any hookups that users have added to your control. The event args class is the other part of the equation. The event args class is what's handed to any handling methods when an event happens. So when the user clicks, the user's the control creator's event is called, and an event args is handed to it. Event args itself is not very interesting. It has no information, but it's a base class from which other types of event args, for example, a mouse event, is going to hand an event args that has a mouse location and a button state handed to it. Key event has the key that's pressed, also control key, shift key, etc., information on it as well. So we kind of bundle these things up, and this is what makes up an event. If you want to add an event to a control, you basically have to do three things. You have to have an add-on, a remove-on, and an on. So if we have an event called action, for example, we would add a method to our control called add-on-action. What add-on-action would do was take the handler that the user gave us and append it to our delegate. Delegates are essentially a linked list. So as you append things to them, they call things in order. We have a remove-on. If a user decides, I don't want to handle that method anymore, you go ahead and have them call that. Looks a lot like the add-on method, very simple. And we have an on. The add-on and the remove-on are generally public methods, and generally the on-action method is a protected virtual. And why is it protected virtual? It's protected virtual because people that derive from a class can then handle that event without syncing the event, without having to call base.add-on-foo. They can simply override on-foo and intercept the behavior first, call the base class if they want to. The base class is generally going to invoke the handler and call any handlers that have been added to that control. Or they can decide not to if that's the behavior they want to achieve. So here's an example from code of what it would take to add a click event to a button. So we have an event handler method, click handler. As I said, that's a delegate. We have static functions on the delegate class, which is part of the Common Language Runtime .NET Frameworks library, that allows it to just take any kind of a delegate class and bind them. As I said, it's a linked list, delete them, etc. We have the add-on there at the top, and that takes whatever the user gave us and add it to that click handler. If click handler is null, we pass it to combine, and it's going to just return us the one the user passed in. Otherwise, it's going to add it to the list. Similarly, with remove on, it's going to delete it from the list that's there and return null if it's the only one. It does the right thing every time. And then we have our protected virtual on click. And on click, as you see there, it looks very C-like syntax. What this says is, go ahead and invoke the click handler with this, which is the object that's going to raise the event, in which case it's our button instance. E is the event arg. And on click is an example where we have the default event arg structure that actually doesn't have any information. It's just so we can keep our signature consistent. So I'm using this button control we just wrote in our event slide here, and I want to add a handler to it in Visual Basic. So we say button1.addOnClick, address of our button clicked method. So one of the really cool things about delegates and the way that works is that even if your method is private, your handler, a class like button1 can get to it because security is taken care of and looked up when we make the declaration, not when it's called. So generally button1 or button wouldn't be able to call your private button clicked method. Because we have security when we hooked it up, the runtime is going to allow us to make that connection. Keeps our handles private, keeps them off our interface so that people can't see them, get them, fiddle with them, whatever. And then when button clicked is fired, we're going to throw a message box that says, hello informs world. Metadata and attributes. You've probably heard this word metadata thrown around a little bit. When you first hear it, it's sometimes difficult to wrap your brain around. Metadata is simply information about a class, about a method, about a property, about a constructor. It describes that piece of data. You can think about something's name or its data, its type, as metadata. They're information about the property. In this case, we have a text property, and we're going to add some custom metadata to it. Custom metadata. Custom metadata is the way that we in the WinForms framework add features and add customization to our design time experience. In this case, we've added a bunch of metadata attributes to a class. And what do these do? We have one here called category. So if you look at the category metadata attribute, this actually maps to a class we have in our framework called category attribute. And category attribute has a constructor that takes a string. So what compiler allows to do here is drop the word attribute so it looks a little nicer, drop the new, and the compiler is going to statically create an instance of this class if the metadata attributes are asked for. So we're going to create a category attribute called appearance. So if this property text shows up in the property browser, there's going to be a category for it if you're in categorized view called appearance. Similarly, description allows to supply a description attribute. What's this text property about? Oh, it's the text to display. Value says text is going to be OK when we create the control. If it's different from OK, we know that we've got a value that's non-default, and we should display it a little differently. And we also have bindable, which says this property is interesting to bind to for data binding. We have a lot more attributes than this. The list is long and not worth showing here, but we have a refresh property attribute which says this property, when its value changes, other properties change, the property browser should refresh. We have attributes that say this property is unique. You don't want to include this in a merge. An example of this is name or tab index. If you select multiple controls in the form, you don't want those showing up in your merge. Metadata goes a long way for us and allows us to add a lot of value to any type of a member type. Visual Basic, here's the text of Visual Basic. We're going to add the browsable attribute to this four-color property. And much as in IDLE with general type list, C++, ActiveX controls, we're going to say this property is not something we want to see in the property browser. So we simply add the browsable false, slightly different syntax, still easy to use in Visual Basic, to the four-color property, and then the property browser is going to ignore the property. So what does this all add up to? Our designer architecture has three levels of complexity. The first one is what we've talked about already. We have objects. We have derived from objects, user controls, custom controls. And we have custom metadata, which controls how an object is going to interact with the designer. The second level, which we're going to talk about in a second, is more intermediate. Type converters and type editors. These things allow us to change how a property shows up in the type converter. Change the way that our designer architecture is going to persist a component to code and from code, etc. More advanced, we're not going to get into in this talk, but there's a white paper out on the MSDN called Creating Designable Components for VisualStudio.net, which talks more about designer services. Just really quick, this is what we built our designers on. We have given to our control creators the ability to hook into our architecture that we use to build the entire designer and the design time experience. And there's services and designers that are really advanced, and the white paper covers some more of that, and I think that we're going to write a couple more of those. It's, as you can guess, a fairly complex topic. But on the other side, you'll be surprised how easy it is to customize the design experience of users with custom controls and user controls. So let's talk a little bit about type converters. Type converters are really one of the meaty parts of our architecture. Converters do a lot of work, and they do 5 basic things. Type converters are all derived from system.componentModel.typeConverter. It's a default type converter, and is often for default classes it doesn't do much. If a control or a class doesn't have something associated with it, we use the default type converter. Type converters are used at runtime and design time. They're more commonly at design time, but they allow us to have a common methodology when you walk up to a class to get information about it. They have no dependency on any UI package. There's no WinForms stuff in type converters specifically, which means that if you want to write controls that have nothing to do with WinForms, that are not directly connected to the Win32 rich client environment, type converters is not going to pull that stuff in. And they enable 5 basic things. One, as the name specifies, they enable type conversion. This is a standard way for us to walk up to a type and say, hey type, can you convert yourself to a string? Hey, I have a string. Do you know how to convert this string into an object instance? Can you convert yourself to an integer? Can you convert yourself to any type you can ask for? And we have not only the ability to convert, but this also adds us the ability to ask first. So we don't generate exceptions, so we can make our code run as fast as possible without having to go to exception handling. Type converters also enable persistence. They say to the designer, this is how I would like my object persistence to code. That object that you create when we ask, hey, how to code is the same object looks the same as the object we'll hand back to you when it's time to create a live instance of your object out of code. So it goes both directions, handles both circumstances. Custom properties. There are cases where you want to modify the list of properties that an object is going to show. If you have a class with a property such as a font on it. Font has sub-properties, font name, font size, underline, italic, etc. Maybe you want to reorder those. Maybe you think, my font decimal double size is not a good property to show. This allows you to customize how the properties show, what order they show in, and it actually allows you to customize whether or not those properties show up in the property browser for sub-objects. Standard values. Things like enums have standard values. My enum may have values 1, 2, 3, 4, etc., and they have names. Type converters give us another standard way to walk up to an object and say, hey, what are the valid values for you? And the object may say, you know what, I can take any object, or any value you want to give me, or it can list values that are only interesting to that object at the time. Validity checking. If I have one of those values or another value, I can walk up to a type converter and hand a value to the type converter and say, hey, is this a valid value for this type? Is colors.red a valid color? Is foo a valid string? Is 272 a valid integer? The type converter gives us a great way of doing that, again, without generating exceptions. Exceptions work really well, but they actually are fairly performance intensive, and we try and avoid having exceptions whenever possible for performance reasons generally. Property editors. The other half of the equation is how does an object or a type show up in the property browser? Turns out the property browser is a really important piece of UI. Users are really comfortable with property browser. They're really interested in what they can do in the property browser. In fact, they want to do as much work as possible right there in a property browser and click things, not add code or whatever. So for complex types, it's great to be able to supply the user with really simple, really rich, really sophisticated editors for a given property type. All of our property editors derive from UI type editor, which is a type editor based on control. We've actually enabled the architecture to have multiple type editors. We haven't created any right now. We have just UI type editor, but the architecture is there for down the road. We can create type editors that aren't based on WinForms. So let's take a look at a couple of type editors, actually. Let's see. This is 2. So here we have the WinForms designer up and running. And if we add a button to this designer, properties browser here. Button has a couple of really great designers added to it. Can't see the scroll bar on my screen. So the first one is the color editor, and when we click this drop-down button, we get a nice editor that allows us to choose custom colors. We can make it red. We can choose web colors, all the standard web name colors that you generally associate with web applications, or system colors, control dark, control text, makes it black, can make it red. Really easy, very similar to the color picker that you saw in Visual Basic 6. We go farther than that, however. We have an example of an editor here. See how this editor goes ahead and draws examples of each of the cursors that we're going to see. The doc editor is one that I really like a lot. We have rich layout that I mentioned with rich control built into WinForms. And the user wants to specify this control should be docked to the top of the form, or actually just the parent of whatever control it happens to be. Then how do I go about doing that? We could have an enum that enumerates all of the options like this. We could say top, bottom, left, fill. But sometimes it's hard to understand exactly what those mean. The doc editor gives us a much richer UI. We can say, oh, I want to dock this into the top. I'll just click this button right here. I want to fill the entire form like this one right here. How about the bottom? No problem. Similar, oops, I'm going to turn that off. Same thing for our anchor editor. Anchoring is similar to doc. What anchoring says is which sides of the control are going to be anchored to the sides of the parent. So if we change this guy to be anchored all the way around, go ahead and make that. Now when we resize the control, this button is going to resize with the control. With UI type editors, you can give your users really straightforward, really rich interaction with your property type. It's totally extensible. It's just associated with a type. If you develop a framework, have some custom types, and ship it to users, they'll automatically get these editors because they're associated directly with your type. Oh, hey, there's a demo. Already saw that. The other thing that we were really interested in when we created the WinForms framework and created the .NET frameworks in general was licensing. We have a story that gives you 100% of the functionality of the column licensing model, but we think it simplifies it on one hand. On the other hand, it creates the ability for component vendors to create components out of their licensing model in and of itself. So if one of our component vendors, such as Sheridan or Farpoint, decides that the standard licensing model, which is a file-based model that ACX used, isn't right for their needs or doesn't quite address their problems, they can create their own. They can even turn around and sell that licensing model if they wanted to as a component in and of itself. So we've created some extensibility in the licensing model that we think is really important. As I said, we simplified it. We'll show some code here in a second. But it's componentized, and it works out really well for people that want to, say, do runtime or design time licensing. It's up to the vendors now with whether we're going to give the design time away for free, but we want people to pay when they run the thing, or vice versa. Design time is what we want to get money for. We want to distribute it as free. Totally up to the component vendors. How does this look? This is an example using the basic, our default lick file license provider that does license file, lick file type licensing. And how do I add this? Again, we have a custom metadata attribute. We add it to the top of our control. We say the license provider is a lick file provider. And all we have to do is add that attribute. And then in control, when we construct it, we go ahead and ask the license manager, hey, is this a valid license of this control in this context to be created? What's going to happen here if this doesn't work is it's going to throw an exception, and the constructor for my control will fail. Control won't be created. If it does work, we hold on to the license, we dispose it when we're done with it. One of the great things about this is you really don't have to build any of the license logic into your control. It's completely separate. All you have to do if you want to change licensing models, for example, is just change the attribute on the top. Code in the control. It's one line of code. It will never change. It's totally straightforward. So I'm going to write a license provider. What things do I have to do? I have to create an abstraction of the class license provider. This is what allows us to reuse it. License, when you look in the framework, there's several licensing classes, but it really comes down to license provider. It allows us to reuse our validation and granting logic, and also allows licensing components, as I mentioned in the last slide, to be implemented separately from the components that use them. So you maybe you have people that are good at security, good at licensing, that really care about how users are able to use it in what contexts. You have people that are more concerned about writing the controls themselves. They don't have to be the same person. They can be separate. You can have a department that writes licensing components if you want to. And as we saw in the component, that we bind it with custom attribute and metadata. So what's the license provider look like? License provider has one really important abstract method, and that's called get license. Get license is going to be called with the first parameter being context. License context is runtime versus design time. So you can choose which behavior you can have different behavior for design time versus runtime. It's up to you. Type. What is the type requesting the license? Is this a button? Is this a my control? Is it a list box? The instance, the actual instance of the control, if you need to access any information about the actual live created object instance, that's passed in as well. And allow exceptions. What this says is this method allowed to throw exceptions, or should it just return null if it fails, and allow the license manager to do the right thing? That's generally the way that it works, but if there are certain cases where if the user calls directly on the license manager, that you may want to throw some exceptions, and the license manager will allow you to do that. So before we actually get to the summary here, we're going to look at an example of how do I create a control. What does the control look like? So in this machine, we have Visual Studio up and we have a design. We're going to create a calculator control. So I could create a calculator control by dropping 15 or so buttons of control and adding handlers for each one. But I think that seems like a lot of work, especially since I have to have this group of buttons for my 0 through 9 and a group of buttons for the operators. So I'm going to write a custom control, actually a user control, that handles that process for me. So over here in our project, we have a user control called button array. Doesn't look like much right now. Button array is going to allow us to have non-windowed, meaning we're going to draw each button ourselves. So it's very lightweight, very fast, and we can organize them in any way we want. So what happens if we add a button array to Form 1 here? If you look down at our toolbox, we have a button array. The designer added this user control to the toolbox for us and said, oh, so you've added a user control to the product, it's added to the toolbox. We can go ahead and build and add it right here to the design surface. Now, if you look, there's a property in here that's very interesting. We'll talk a little bit about a little more about it. Actually, two properties. One is button item property, and it's a collection. We'll talk about this a little more in a second. But this is how we add our items. We can go ahead and add items here, and you see there's an instance of the property browser over here on the right side. When we hit OK here, we're going to add some buttons. And now we've got some UI to it finally. And the buttons are in a layout that we don't really like. We kind of want those to be laid out a little different. So we're going to go down here to layout property, and it's actually a size. So we have width and height. We can expand it like a lot of the other properties, and we can change it if we want to. If we want it to be 1 by 5, we can do this, and we'll go ahead and repaint and change it. But you know what? This is kind of hard for our users to use because we can't control how this is manipulated. If I add some value that's too small here, I'm going to get an exception that says, oh, 1 by 1 is not big enough for me to fit all these buttons into. I'm going to have to put an error. It's kind of hard to use. So we're thinking about how is it easier for us to add rich design time support to this. So we decided to create a layout UI control that's going to be our property editor for this property type. So here's an editor. It's just another user control that's going to allow users to do this in a much easier way. So how do we go ahead and make this part of our behavior? So if we go back to our button array class that we created, again, it doesn't have very interesting UI at design time, and look at the code. We're going to use, like we've talked about a couple of times, metadata attributes to make this work. We go ahead and we find our layout property, which is the property that we were looking for here. Hang on. All right, there it is. We're going to modify its behavior. We've actually created a type converter for this property and a type editor for this property. If we want to look at how those are defined, look down here. So this is pretty much the size converter we just looked at. It's got the plus, etc. But we don't want the plus to show up. So we're going to override the size converter. And we're going to say, when the property sees this object, is going to say to the type converter, hey, can I have subproperty of this? We're going to change this behavior and say no, false. We don't want to see the plus. We don't want to be able to look on this thing. The other thing we're going to do is we're going to add a UI type editor to it. The control I just showed, we're going to want to put in the drop down when the user clicks on the property. And how do we do that? We just create the layout UI control. That's what I showed in the other designer right up here. And we're going to simply say to the editor, the iWinForms editor service, hey, take this control and drop it down. Really straightforward, very similar code every time you do this. So let's take a look at how to add that to the property. Let's find our layout property again here. We just add the metadata attribute. Here it is. Let's see, let's put it right here. So we have the editor attribute class, and as I said, the compiler allows us to drop the attribute word. Type of layout editor is what we're interested in, and it falls into the UI type editor class. As I said, we've enabled the option multiple types of type editors, even though we're not actually using any other types. Type converter. A lot about type converters. This is what's going to allow us not to have the plus sign there. So go ahead and build this. And we go back to this. It's going to cause the form designer to reload because it saw that we changed the user control that's on the form itself. We go back to the property browser over here. And if we look at the layout control, notice the plus is gone. We have a drop-down arrow. So when this drop-down arrow goes, all of a sudden, now we have a much richer UI. And we change it. So now we've put some code in there that says that we want to make sure this is balanced. If the user changes the value, we want to change the associated columns or row value so that it always stays to be the right numbers. And we do that, and it goes ahead and changes the value. So that's great. Now we have good, rich UI that we've integrated, but we want to create a calculator control. How do we go about doing that? Let's delete this guy here and add a new one so we don't have any leftovers. Add one here. So we add a control that's going to have our keypad. This is going to be the buttons. How do we go about doing that? So as you saw earlier, we can add a whole bunch of buttons to this thing. And I could go in through and type 0, et cetera, on these. And there's the letters. But it's kind of a tedious process, so I'm just going to do the major demo way here and drop in some code. Oops, let's go back here. Rename that guy first. delete these guys. So another thing that's interesting to point out while I'm doing this is that we actually use code as our persistence model. There's no other file that describes how our form is laid out. We have two-way code binding. Generally, users won't need to muck with what's in an initialized component, which is the function that I'm in right now. But opposed to previous versions of other products, we've decided to make this not read-only. The user can change it. Our parsing is much more robust. You can change it. There's certain things you can't do. You couldn't say that button.text equals button2.text. We're not going to know how to understand that. But you can change the code if you want to, if you do it in very simple ways. So I've gone ahead and created the code already so I don't have to type in all these values. So I go back and now we get a nice keypad there. But we want to change that layout a little bit. We want to make it look more like a calculator. So we're going to change it to 3 by 4. Oops. So now we have a better looking thing. And we're also going to make sure that this thing stays in the same place no matter how big the form is. So we're going to anchor this. We talked about anchoring a little bit before. We're going to anchor this to each side so that it stays put. Now what happens if I resize the form is it kind of stays put and resizes nicely. Let's get a little closer to the bottom here. Just one more time for our operators. And we don't need many of these. We're going to go ahead and modify the right in place. So we've got a plus and a minus time. And again, this is not the layout we want, so we go ahead with our layout editor right here and change this to 5 by 1. Oops. That's not supposed to happen. Okay. Lost it. Oh, not 5 by 1, 1 by 5. There we go. So now we have something that's starting to look like a calculator. We can take this guy, and we can also use anchoring to control how this control interacts with its parent, being the form. So now we've got a nice resizable window here, repaint. Looks nice no matter how big it is. We don't have to worry about different resolutions anymore. And let's add a text box to the top of this. The controls where our user is going to do his interaction. So we align this to the right. Oops, there it is. Change the value 0. Text box 1 is kind of hard to do math with. And it's probably small for people in the back, so we're going to make this text a lot bigger. Let's try 26. There it goes. We're going to dot this to the top, so it sticks up there. Boy, now we're starting to look at a calculator. Let's add some logic to this. So we go back to the code. We add some demoware pre-canned logic. You could watch me code this up from hand, but you'd be here for hours. Turns out that when you first sit down and think about writing a calculator, it turns out that it's harder than I thought it was going to be. Once you get it right, it's one of those pieces of code that once you get it right, you're like, oh, duh. But the 10 or 12 iterations before that turn out to be kind of difficult to get right. So there, and then what's going to happen? This is what's going to happen when we click on the keypad. What we're going to do is this one's really easy, right? We're just going to append whatever character was clicked onto the number. But we also need to, the really important logic, turns out, is in the operators right here, and you'll see in a second that this is actually where the complexity comes in. But it actually turns out to be not too bad. We just simply parse the integer. int32 has built-in parsing functions, the int32 class, in the .NET frameworks for how to handle converting a string to an integer. Just parse it out, and then we do the right thing based on which operator was clicked. And it's all text-based in this case. Our button control, let's actually take a look at that. We've added events to this control. Oops, at the top here. The default event is button clicked. So we have a default event attribute which tells the property browser and the form designer what happened when we double click on a control at runtime. And we've got our event handler here. It's simply going to be called, let's go down here. It's going to be called when the user clicks. So the user does an add-on click right here, and we combine it with the existing handler like we saw on the slide earlier. And then when the user actually does the click, we're going to invoke the handler. So that's what we're doing back here. We've added some code that's going to happen. Oops, wrong thing. There we go. That's when it happens. So we're going to build this, cross our fingers that it builds. I think I got all the steps in there. Let's try it. Very, very cool. Back to the form designer. So we've added all this code that wasn't an initialized component. earlier, we dragged in the code that had the whole button array, all the 1 through 0 in there. We modified that code, we changed the code, we reloaded the form designer, it picked up the state from the changes that we made, and is unconcerned with the other code we added into the event handlers itself. Let's run this and see if it works. Turns out we've got a control that looks like a calculator. It resizes very nicely, any resolution we care about, and it actually even allows us to add and subtract values. So it turns out it works. So what do? We spent 5 minutes. We created a rich application that really took advantage of some usability and some designer enhancements that is built right into the core of the WinForms framework. It allows us to customize how a user interacts with special types that we've created. Layout type is the example we used here, and allows the user to also customize existing behavior, why we got rid of the plus for the layout editor. So where does that leave us? We've got a framework easy to controls. This framework is all about deriving from base classes, utilizing candy behavior, utilizing the component framework that we all know object-oriented programming gives us. It allows us to get really easy painting effects that are really cool. We had the .NET GDI Plus demo we did earlier. Really wasn't the hardest part was figuring out where the points should be. We can do transparencies built right into the platform. You can do non-rectangular windows. You can do fills. You can do gradients. You can do some of the other really great stuff I showed yesterday. Easy to integrate into design time. You can customize how a component interacts with the designer. You can customize how your licensing scheme works. You can customize just about anything. We haven't forced any part of our architecture on the users, on the component creators. We want to have a lot of flexibility in the people that are using our technology to create really great controls that we haven't even thought of. It's very easy to get into a situation where you kind of funnel people in a given direction. We wanted to take the other road and just open it up as much as possible. And as you look into the framework, if you read the white paper, the customizing components for Visual Studio.net, you'll see that we've opened up a lot of the hooks that we're using to write our designer to any of our users. So as I said, there's some other sessions that are really interesting. There's security considerations. If you want to take this control you've written and put it in IE, I think that talk is in this room directly following this one. How does that work? GDI Plus and WinForms, I think that's also later today. Deploying and versioning your application. I write this control, I decide to change it. How does that work? What is the deployment considerations there? I'm actually not sure when that one is. Similarly with framework security. General considerations. Quick start. The quick starts are great. Go to the web, look at the quick starts. They're on MSDN. They'll get you rolling really fast. And as I mentioned a couple times, the creating designable components for the Visual Studio.net designer. And that's what it comes down to. Any questions you have, I'd be really happy to answer. Yeah. Yeah. Yeah, I think we're turning it on. Can we turn the mics on? There we go. I think we're on.
At yesterday's talk, they were talking about using a WinForm control in IE 5 or 5.5.
Yes.
What becomes the container in that case? In other words, if I'm using the anchor properties, do I anchor to some sort of artificial container in the form, or do I actually anchor to the browser itself?
For all intents and purposes, your container is going to be the user control you started from. It's going to react properly to resizing of the browser based on the object container that's around it. But all ActiveX sourcing is built into the control.
I'm not sure I understand.
Yes.
Okay. Yeah, okay.
Thank you.
Hi. I was wondering how much of Visual Studio itself was written using the same sets of components. So that is, like this is like Delphi again, right? So
I'm sorry?
This is a lot like Delphi again, right? And so the question really is, in Delphi, since Delphi's IDE was written using Delphi, is the current Visual Studio written using essentially the same sets of components?
Let me switch screens here really quick. Visual Studio itself, the base of Visual Studio is not written using forms. However, many of the components that you interact with seamlessly in the Visual Studio environment are. Over here we have the Server Explorer. A great deal of Server Explorer is written using WinForms. and .NET frameworks in general. Over here we have the property browser. I think I just, oh, there we go. The property browser that is written completely in WinForms, every part of it. The WinForms designer here, this is all WinForms. So it's kind of sprinkled about, but interacts very well. The COM interoperability story with the CLR is very clean, and we're able to get a lot of performance benefit out of that.
So can I actually, because one of the fun things a lot of folks did in Delphi was to hack into the IDE to do custom extensions. Are the extensions done via managed code now, or are the extensions still done?
Our extensions are. For the WinForms designer, they are. All the way down, really to a really low level, we've written WinForms extensions, and we're working out how our SDK is going to look, so we're going to allow our users to use the same extensions that we've worked on that hide the complexity. Well, so yes, absolutely.
And one last thing, is the editor hittable via managed code?
The editor. It's hittable. Yeah, we don't have any classes that allow you.
But the editor isn't written in managed code, is it?
No, the editor is managed code.
Okay, thanks.
Sure.
I'm a VC guy, and all this stuff looks like VB for me. And as far as I've seen, it's like easy to create fancy about boxes. I'm kidding, but I know MFC, I know ATL and some kind of WTL. So my main concern is I want to write a real-world application, not a fancy about box.
Sure.
So is there any framework?
Yes.
You see what I mean?
Can I have this microphone? Can I have this microphone on? So if you look at the property browser, if you look at the Server Explorer, if you look at the property browser, look at the Server Explorer, if you look at some of the simple applications I showed yesterday, a customer detail form, I think they're very good examples of real-world applications. If you look at the property browser, although it's very simple to use, internally it's a massive and complex piece of code. It's hosting value editors, it's dynamically looking up types at runtime, all those sort of things. For me, that's a superb example of something that will be very hard to write in MFC, for instance.
Okay, it's like controls. I understand that it's easy to write controls, but a real framework application like splitters, like docking bars and everything.
It's funny that you ask.
Is it easy to mix Windows with 32?
Take a look at this.
Controls.
This will probably answer your question.
Yeah.
This is called Windows. This is our what we call self-hosted designer application. The application you're looking at here is written 100% completely in WinForms. We're hosting the prop browser. We're hosting the form designer. This is 100% in WinForms, and you mentioned splitters. There's a splitter here. You've got MDI windows. All the semantics of a real-world application are here.
Okay.
Does that help?
Okay, it's a C#.
Yes, this is 100% C#.
Okay.
Could be Visual Basic just
We
as well.
also actually have a version of Visual Basic.
Yeah.
I don't have it on a machine here, but back at the office we have a version of it that's completely written in Visual Basic as well.
Okay. So the additional question is, do you have a name for your framework?
.NET Frameworks, WinForms. Our framework, part of the .NET Frameworks is WinForms, but the overall umbrella term is .NET Frameworks. And .NET Frameworks is huge. There's so much functionality in there. There's net interaction framework for HTTP requests. There's data. There's I/O. It's a very large framework. So .NET Frameworks is the overall.
A last question. Do you have some special in memory DC to avoid flickering, all this kind of stuff?
Actually, it turns out we're not using a lot of double buffering memory DCs. The property browser is an example. There's a tiny bit of flicker in there, but there's no double buffering going on at all.
Okay. Thank you.
Sure.
Can I call directly Win32 APIs
Yes.
from WinForm?
Yes.
And another question: can I get access to window handle?
Yes.
For WinForm?
Absolutely. There's a handle property actually on control that returns an integer that is the window handle. If you need to do that.
Thank you.
Sure.
This all looks great. Good job.
Thank you.
After I get all this done, I get these great applications, I got to turn it over to somebody who documents it.
Okay.
Can you either demonstrate or say
Sure.
what the help extensions are for?
So which, do you mean the usability control itself?
Well, I mean if I'm building a third-party control.
Okay.
Unless I do a really good job, somebody's got to figure out how to use it.
Sure, I'll show you exactly how that works. So one of the things we've done is integrated the help story with the authoring story. Just missed one here. So if you look in here, you see there's this kind of bits of XML here. So there's actually a tool that takes XML and generates help application. I wish I could show it to you guys. But back at Microsoft, when I want to see, I can't remember what the members on type are, we actually have a website that is generated dynamically every time we have a new build of the runtime.
Well, Mike, that's what I thought you were going to say. Now, my second question is, what I'm talking about is I want to distribute this to third-party people. I want to document the whole application.
Okay.
And what maybe you already handle it, and I'll be happy, is that all my internal stuff, I don't want going into the help file, or I don't want, I want two versions.
Sure.
One that's external, one's internal. Does it distinguish between private?
Oh, it doesn't.
Public?
Yeah, you can. There are XML. We don't have any in here. There are XML tags that tell the help engine, don't spit this into the help file.
But I mean, can you do different levels? And if you don't, then that's something to think about. That I want to generate a help file that's external.
Yeah.
Run it again. Give it to my developers.
I'm not aware of any where you can create different versions in the same file. I'm not aware of any extensions that do that. I don't think.
And then the last question on that is it extendable? Can I go in and add a new XML extension and then write something that it spits out?
Yes.
And then the last simple question is, do you know the size of the runtime for this?
The redistributable?
Right, to go back to an ancient operating system like 98 or something.
Yeah. I don't know how big the CLR is going to be.
I don't have the figure to hand either, I'm afraid.
I actually don't know. It's not going to be massive.
If you come along to ask the experts tonight, I'm sure we find somebody.
Yeah.
Because I'm afraid it's going to be 60K for my control and 17 meg for the runtime. So.
Yeah, we'll get it. Please come to the Ask Experts tonight. We'll find a person that can tell you.
Guy over here in the nice net T-shirt.
Okay, given you have a WinForm application done, and now you decide parallel or as an alternative, you want to have a subset of that as a web form application. What is the strategy to do that?
So whilst the programming models are similar and the control models are similar, we don't have anything that automatically turns a web form control into a WinForm control or vice versa. It's something that you'd have to design in from the beginning. So one of the things you could, for instance, do is, if you take the chart control I showed in the browser yesterday, is to build a web forms control that sniffs the browser type and renders the chart as a PNG or a JPEG. It's nav3, and then downloads the control if it's IE5 plus the runtime. But in this version, we have nothing that makes that an automatic process where you kind of add an attribute to your control and suddenly it's a web forms control or a WinForms control.
But it's very parallel. If you look at the web forms framework and the WinForms framework, one of the things we've really tried to accomplish in the .NET frameworks is that if you look at them, it's very clear that everybody's on the same page and they operate very similarly.
One thing that came into my mind is maybe it would help to deliver an XML generator that generates one sort of XML out of the web WinForm controls that you can read in and transform or translate to something that is more similar to a web form. Maybe that would help.
Yeah, I mean, they're the kind of things we're looking at for the next version.
I was on the Win32 stuff. You can get callbacks right from it's like Enum Wins or something, right? Mm-hmm. How do you do that in this stuff? Because that's kind of weird, right?
Yeah, it turns out to be obviously more of an advanced topic, but that's exactly what we have to do for our WinProc, right? We have to pin it to it, and you create something called a root, which is essentially a pinned piece of memory. You hand that over the boundary, and then Windows, when it calls in, runtime does the right thing and calls our code.
Is that docked anywhere?
Is rooting docked anywhere? Yeah, okay. Right, okay. All delegates can be passed over the boundary, and they automatically become the right thing on the COM native site. Yes.
Oh, that is so cool.
That's right. I forgot about that.
Are you actually going to ship, this is like the nasty question, right? Are you actually going to ship stores for this so we can actually see how?
We're certainly investigating that possibility right now. we actually want to ship. We really want to get this stuff out to you in a release form. We're also very interested in helping people develop controls. We're trying to balance those.
Yeah, because that's where the education is.
Yes, we completely agree. We're completely on the same page.
Yeah. Okay, thanks.
Hi. Do you have any kind of document provision, like you have in MFC, like document from templates or ActiveX document? How do we manage document with WinForms?
Do you mean document view architecture, or you mean standard implementations?
Both things. Document view is something that I use a lot in my applications, and I would like to have an idea how to develop an application that is able to handle different kinds of documents using WinForms.
Right. So
the simple answer is no. Don't have anything like the document view architecture in MFC. It's something that we looked at for this version, and we decided we had other features which were higher priority for this version. It's certainly something we'll look at for future versions.
And your second question was it a two-part question?
No, but it was.
So if you don't have, you don't have. So
it's still possible to separate your layout and view from your data. It's most of the layout and most of the view is contained in the initialized component.
When we go to handling menus and merging menus between different MDI windows, is there any support for that?
Absolutely. I don't think I have the sample on the machine, but if you look in the quick start, there's a couple of MDI samples. One which does menu merging, including merging into the same menu, adding extra menu items as you change between child documents. It's pretty straightforward, pretty simple to do.
Thank you.
I have lots of 3D type applications. You've shown some GDI examples. Is there any way of binding to any of the 3D APIs?
You mean the DirectX type stuff?
Right, or OpenGL.
So GDI Plus is a 2D drawing package.
Right. So if you go to the advanced C# talk, I believe one of the demonstrations they have there shows using the DirectX 3D API in a WinForm application.
Is that right?
I believe so. Yeah, I'm getting nods from Chris down here who knows what's going on. So go to the advanced C# talk. They're using C# to call into the Direct 3D API, doing 3D real-time rendering as one of their demos. So.
Thank you.
Yeah, I have a couple questions that will probably lead into one. I'm kind of one of those guinea pigs out there that use the product diligently, referring to like ActiveX documents, which one of those that failed miserably. But more particularly, what I don't hear here, like the property bag, do a lot of stuff with intranets, corporate intranets, trying to envelop the ActiveX technologies into the browser is somewhat cumbersome because of the human factor. You know, refresh just kills everything. What is it we can expect in the ActiveX form in the way of a property bag in the new change-up from the property model that you're using? And is this just another evolution out of ActiveX documents?
So this is not an evolution out of ActiveX documents. I'll start by saying that. I'm just trying to make sure I understand your question. What you're talking about is you put a control on a web page. When you hit, you change some state in that control, and when you hit F5, the control goes back to its initial state. The change in state is lost because the web page just simply gets reloaded. Is that correct?
That's correct. Is there an override to override the refresh event?
I I've done some prototyping, and this is currently something we're looking at. One way to solve this problem is to actually encapsulate the web WinForms control that you're using in a web forms control and store and actually keep the state of the control on the server. So when you hit F5, the state is round trip, and you don't lose state.
Is this going to be documented, or am I going to have to buy a Daniel Appleman book on this?
So I would like to think we'll have some samples that show how to do these kind of things. Depending on what my workload's like, it'll be beta 1. If it's not beta 1, it'll certainly be beta 2.
So maybe I should wait on this.
Right. Well, my advice would be with the sample I showed yesterday, the chart control in the browser, we'll be shipping that in whatever release format there is for all the post-PDC stuff. I'd suggest you start having a look at that. I mean, it's still a beta, there's still bugs in it, but it'll at least help you understand. And just so everybody's clear, when we host WinForms controls in the browser, they're activated as native COM+ components. They get activated in the correct security context, so there's no problem with you put a control in the browser, it has direct access to machine resources.
You guys have done a great job. Thank you.
Thank you very much.
One more question about the new forms. In VB, you had a COM model about the project, the forms, and all the widgets on the forms. Is a similar API available with the new paradigm?
So you mean the designer extensibility model inside the shell?
No, I need to write a program that is telling me how many buttons, how many text fields I have in a form.
At runtime.
At runtime, of course.
Yes, you can absolutely do that. The form has a controls collection. You can just simply iterate through the controls collection, find out how many text boxes, how many buttons you've got on the form. Dynamically add and remove controls at runtime. Dynamically add and remove events.
And with property bags, I had that capability also at design time. That's still possible? I mean, with property pages. So you
right, yes. So at design time, you can get to the site for a particular control. You can get to the container. From the container, you can get to the designer services. You can use the design services to find out what components got on the form. For instance, I've written a control that when you drop it on the form, it doesn't instantiate that control. It just gets hold of the designer service and instantiates other controls as a result. So it's a pretty rich model.
Thank you. Great.
All right. Thanks for coming. Hope you enjoyed it, and look forward to hearing comments. Thank you.
Thanks very much.